Okay, this video is going to take you through a program called Updating Memory Locations. It's going to show what happens to memory locations in the computer storage area during a program. And this is very important to understand. Before we get started though, what you'll need to have is a piece of paper in front of you. You don't have to have this program open to you up to you in the JGraphs, because you can just see it on the video and that should be good enough. So you should have a piece of paper. If you haven't got that yet, make sure you pause the video and get that. So what you would want to do is you want to label it, as we have here, computer memory. So this is computer memory right here. And these boxes they all represent storage locations that are already in your computer's memory or storage on its hard drive. So there's lots of memory or storage locations there that are not being used yet. And so we're only going to need 3 of them, but I put more than 3 just to illustrate the fact that there's a lot more in here than what we're actually going to use. And so what happens is you should have at least 3 boxes out here, because we're going to use those 3 in this program. So what happens is we're going to come to this first line program statement in the main method, and the question is, what does the compiler do with this code? Well, what happens is, first of all, we call this a declaration with initialization. Remember, declaration means it's got a data type and a variable. This right here is all that's required for a declaration. But this particular declaration also has an initialization, which means it's being assigned on the same line as when it is declared. And so this declaration of int x is when the programmer is declaring, so to speak, to the compiler that we want a memory location to be reserved for this variable called x. So it's like when you call a restaurant and you reserve a spot for your family at the restaurant. And so that's what this does. It reserves. So it goes over here into the computer memory and picks a cell that's not being used yet, and it declares its name. In this case, we're going to call it x. So we're going to say the name is x. And then it configures it, so to speak, to be an int, which means actually that it's going to be just a certain length. It's going to allow, it's only able to use so much memory because of it being an int, and so it'll only take integers. And so then it takes this assignment operator, and it says we want to assign 10 to this memory location, so it puts a 10 inside of that memory location. So that's what that statement does. And so what we could do then is, if we wanted to maybe type it out, this is what you should recognize. This question will be asked many times, and probably on a quiz coming up soon and a test, is what does the compiler do with this declaration, with this line of code? What it does is it reserves a storage location or a memory location in the computer memory. Okay, so this is actually going on the hard drive of your computer. It's in the background. See, this is not like a print statement where it's obvious. Well, it displays something on the screen. This is all going on in the background. So reserves a storage location in the computer memory, names it X, and it stores 10 in it. Okay, so that there are 4 parts to this answer. It reserves a storage location in the computer memory. It names it X, and it stores a 10 in it. Okay, so let's get this right. Okay, and so that's what that line of code does. Now the next line of code does the same thing, only it's going to reserve a different memory location, and it's going to give it the name X or Y, and it's going to store a 5 in it. So this is a declaration with an assignment or an initialization. Okay, the next, so we've done these 2 lines of code. The next line of code, what is this called? Well, this is also called a declaration, only this has the minimum amount required for a declaration. It's got a data type and a variable. So the thing to remember is that a declaration, all it needs, the least amount that it needs, is a data type first, followed by a variable or a variable name. That's what a declaration has. But it can include an initialization. And so again, as we've mentioned before, this is the declaration. This is the part that reserves the memory or the storage location, and this is the part that stores a value in it. Okay, so now we go int z. So this is a declaration. It takes another memory location and it reserves it, and it gives it a name. In this case, we'll call it z. Alright, then we go down here to the next line. Now this does not have a data type. So this is not a declaration. What this is, and you can tell because of the symbol in here, the operator is an assignment operator. So this is an assignment. And the question is, how do you read this? And so you read it as there's a couple ways that you could read this actually. And so we're going to go back here and make it so you can see this. So it's read as this: X is assigned 8. X is assigned 8. Or 8, if you want to read it from right to left, you'd have to say 8 is assigned to X. Now the important thing is to remember, and this is what's going to trip people up, and this is what's going to cause people to lose points on tests, is this word to is huge. It only can be used when you're reading it from the other direction, from right to left. So here you have X. X already exists. This memory location already exists. And then you're going to assign it an 8. Okay, here, if you want to say 8 is assigned, so you can't say X is assigned 8. You don't have some 8 sitting out here and go, okay, we're going to assign X to it. That doesn't make any sense. You have the memory location first, and then you assign an x to it, or an 8 to it. Now, but you could say that 8 is assigned to the variable x, or to the memory location. Okay, so let's get rid of some stuff here. Okay, so now the next thing here is that the next line of code is this one. Well, actually, we'll do this a little bit different than in class. When x is assigned 8, that means this. It means that it's actually going to, and what you can do is you can actually cross this out and put an 8 in its place, because that's really what's going on. It's replacing the previous value of that variable. I could actually just delete that part with this eraser. So now instead of being 10, it's 8. Then we come to, so this is what we call updating the variable. It's been updated from being 10 to being 8. The next line, line 10, it says y, it is assigned y plus x. Now here's why you can't, well, yeah, here's why you can't say y is equal to y plus x. This is why we don't say y is equal to. Because y is 5. And y here is 5. And x is not 10, it's 8. Don't look here for the values of your variables. You look in your computer memory. That's why this is important to do this kind of thing on paper. So it's 8. 5 is equal to 13. Makes no sense. That's why we don't say x is, we don't say is equal to. We say, instead what we do is we say that the storage location y right here is going to be assigned the result of x plus y. That's how we read this. X is assigned the result of this calculation, y plus x, or it's assigned the sum of y plus x. And so y is going to be assigned 13. So we're going to go over here and we're going to make this 13. So now the y variable, or the storage location or memory location, has been updated to 13. Now it's also important that we understand x here. X is, you have the variable name here. This is when it's stored as a reserved memory location, and then we have x being assigned, but this x is using the value of x, which is 8. It's using it in the calculation that will be stored in y. And so this is called a variable call. Alright, so this is a variable variable call. This is when x is being, a variable is being used. So x is declared up here, it's assigned here, it's updated with an assignment here, and then it's called here. So it's got to be declared, then assigned, and then used or called. Alright, then the next line of code is x is assigned, and just, yeah, x is assigned the sum of y plus z. Well, y is a variable call, and so it's calling the value of y. Y is now 13. So again, don't look up here because the memory location has been updated. So it's 13. And z plus z. Now z, it's calling z, so the The compiler goes into the computer memory and tries to find the memory location Z, and it finds it right here. And then it tries to grab its value, but there's nothing in here. So it's called a garbage value. And so this is what causes the compiler to give you an error message. And it'll say that this variable Z has not been initialized. And the word initialized, of course, means assigned. It's never been assigned anything. As you can see, it's just been declared, but it's never been assigned. So you can't use it yet. So this will produce an error message. So, let's see. Let's pause for a second. Okay, so what we're going to do is we're going to show here how this will actually produce an error message because of this variable call. It's trying to call a storage location that's empty. The compiler doesn't like that. So let's go ahead and compile this. So you can see it says uh-oh. You know, it helps if I make a comment there. And let's try this again. Okay, so it says in this line, which is 11 right here, that in 11 it says error, variable Z might not have been initialized. So the variable Z, in fact, has not been initialized, has not been assigned. And so there's an empty. There it's empty, and so it gives you the error. So what let's do is we will then fix that, and we'll go ahead and initialize it up here in the declaration. Give it a 3. And so what's going to happen then is you got a 3 here. Now you're going to see that even though X started with a 10 and Y is a 5, you're going to see that it's really, when it prints right here, it's going to print the value of X. Well, actually it's going to print the values right here. The values are going to be 8 and 13, not 10 and 5. And so we will now recompile, and then we will run it. And then you can see then that it says that X, oh, I forgot to do this though. That's really good here. So I forgot to do this. Here's 3. And then Z is 13, or Y is 13. So X is assigned 16. And so over here, X is assigned 16. And so that's why we get 16, 13, and 3. So right here, 16, 13, and 3. Okay, the last thing we need to check really quickly here is this code down here says X is assigned Y. Now again, we don't say X is equal to Y because X is 16 and Y is 13, and 16 doesn't equal 13, so it makes 0 sense. So how do you read this? X is assigned Y, or Y is assigned to X. Well, we're going to take Y, which is 13, and we're going to assign it to X. So X will be updated now. From 16, it's going to be updated to 13. And then Y is assigned 2 times X. Well, X is no longer 16, so it's 2 times 13. So this is another variable call, and so Y is assigned 26. And so we go over here and assign that is 26. And then if we were then to remove the comment symbols, then it should print X is 13, Y is 26. And so we will compile it, and we will run it. So x is 13 and y is 26, which is exactly what happened as the memory locations were updated. Alright, that's it for this video.